Anybody else who hear my voice? Is there anybody who's not here today? Do you guys recognize somebody who's gone? Cade. Okay. All right. So, Steenie, you want to say hi to Cade?
Hey, Kate.
Tell him about the cookie he missed.
They're really good cookies.
They're really good, and you don't get one. Actually, well, maybe we'll save one for you. Doubtful. Chances are they'll be eaten tonight at Angie's house, right, Angie? Ooh, next class. Sorry. All right, maybe we'll bring one for you later. Anyway, here we start. We have exponents and radicals. I spoke with Miss Nelson about this topic. She said, should I cut down on how much time I spend on this in Algebra 2? I said, no. I said, I try to go over it fairly quickly in pre-calc, and I said they still struggle with it somewhat. If you took trig last year, you've kind of had a year off from exponents to radicals, so this is going to be something you need to give some definite attention to tonight. So please pay careful attention to this stuff. We're going to go over the rules, and then we're going to try a bunch of practice problems. It will take us the majority of the hour, and you have to work on this tonight. If you don't finish your entire assignment, again, it's not due till test day, but do come prepared with a question or two tomorrow that we can go over. So we begin. Rule for exponents. First one, anything to the 0 power is 1. How do you remember that? Well, a squared over a squared. Anything divided by itself is 1, right? And if you were to subtract the exponents, you get a to the 0. So that's the way to remember that. If they have common bases and you're multiplying, what do you do to the exponents? Add them. So this is a to the m plus n. What if you're dividing? So that's a to the m minus n. What if you have two items that are being multiplied and an exponent on the outside? Raise both of them to the exponents. That becomes a to the m, b to the m. So you can distribute exponents over multiplication. Can you distribute exponents over addition? Is this equal to a to the m plus b to the m? No, you can't do that. She would probably cut your finger off. Have you seen her fingers? She got, well, she had a little accident. She's got some Band-Aids on them. You'll have to ask her about it. Okay. A over b to the nth. Does it matter if you're dividing? Nope. You can still do a to the nth over b to the nth. So you could distribute your exponents over multiplication. You can distribute your exponents over division as well. But not addition and subtraction. What if you have a negative exponent? Flip it. B over A to the nth power. The way we get rid of the negative is we flip it, and then we go ahead and take care of the exponent, which would be b to the nth over a to the nth. What if I have a negative exponent on the bottom and a negative exponent on the top? I put them where they're not. So the a to the nth will go on the bottom and therefore make it positive since you moved it. The b to the m goes on the top. So that's the movement that takes place. So those are our exponents. We're going to do our radicals now. Any questions that you see about the exponents? You remember those? Okay. When we throw them into some problems, you might encounter a little bit more difficulty. What if I have square roots? What if I have the square root of a, b? How can I divide that up? Good. Square root of a times the square root of b. So like if you had the square root of 50, you could divide it into the square root of 25 and the square root of 2. So if it's multiplied, you could divide them up. Okay? If it's divided, you can write it as 1 square root. That might be helpful as well. And the last one, yes. Exactly. So you could go from here to here, and you could go from here to here. Same way here. Here to here, here to here. Either way. And so one property might be more useful at one time and then the other another time. Number 10, can you write that using a fractional exponent? How? A to what power? Where does the m and the n go? Good try. You're thinking of logarithms. Not quite. The m is attached to the a, right? So that stays in the numerator. It's the index that goes in the denominator. So for example, let's say you had the square root of x to the fifth. That's the same thing as x to the 5/2, because 2 is the index on the radical there. Remember that? Yeah, kind of comes back, right? That's why we review. Okay, so let's do some of these basic operations then, okay? I'm going to change this to -2 to the fourth. Okay, 4 to the third. What's 4 to the third? 64, okay? Just multiply it 3 times, okay? -2 to the fourth. Is it -16 or +16? Those are different. This means that you're taking 2 and multiplying it 4 times, then making it negative. This means you're multiplying -2 4 times. So the negative goes to work 4 times in this one. How many times does negative go to work here? Just once. So will the result be positive or negative? It will be negative. And so a lot of times when people get to their calculators and they type in, they'll be like, well, Mr. Gens, I did it on my calculator, and I got -16. Well, sure, -2 to the fourth. Well, your calculator is doing exponents first and then multiplication, and it gets -16. You have to type it in with the parentheses. Right? So, -3 to the third, -27. The negative is being applied 3 times. It does result in a negative. 11 to the 0. Square root of 144. Cubed root of -125. -5. Can you take the cubed root of negative numbers? Can you take the square root of negative numbers? No. So you can have an odd index for a negative, but not an even index for a negative. As long as we're working the real numbers, that's not possible. Now when we get to complex numbers, it's an entirely different story. I just thought of something I wanted to tell you, but I should wait. Okay. Fourth root of 81. Good. Now, if you need to make a chart of perfect squares, perfect cubes, perfect fourths, go ahead and quick make a chart somewhere, on note paper. You can keep in your book or something if you need to remember those. But, those are things that we should kind of keep in mind here, okay? 2 to the third times 3 to the -2. I want to simplify that. What should I do first? Okay, good. So I'm going to rewrite this 3 to the -2. So I have 2 to the third over 1 times, how do I rewrite 3 to the -2? 1 over 3 squared. Now I've gotten rid of the negative exponent. Now it looks like something I can simplify. What is 2 to the third? So I have 8 over 9. So 8/9 is what this simplifies to. Any questions on H? Okay. Here I have 1/3 to the third power times 6 squared. Which operation would you like to do first? Want to do the 6? We can do that. So 6 squared is 36. How do I do 1/3 cubed? So you can cube the top and cube the bottom, or you can multiply 1/3 3 times. Either way, you get 1 over. I'll write them both as fractions. Can you simplify 36 over 27? Both have a factor of 9. Divide them by 9, and as Scott said, we get 4 over 3. Okay, I can't resist. I have to show you. So like we took the cubed root of negative 125, right? And you know, you guys know what the square root of negative 25 is what? 5i. Well, I'm going to show you later on second semester how you can find the square root of 5i. In fact, I'll show you. I could do this. You can take the 16th root of 5i plus 1. It's crazy. It's really crazy. But it's so cool. It really is. It really is. All right. Okay, so now I got the square root of 5 times square root of 45. So you have options for how you want to do this problem. Generally, there's two ways that people choose to do this problem. When you first see that and you want to simplify it, what is your first reaction? What would you like to do? Okay, you want to break the 45. That's the way everybody said so far. So we'll do that. Square root of 5 times the square root of 9 times the square root of 5. Well, when you do that, you see, well, they share a square root of 5 in common. What's the square root of 5 times the square root of 5? Square root of 25, which is 5. What's the square root of 9? And 5 times 3 is 15. Excellent. What is the other way to do the problem? Just multiply. 5 times 45 is, and the square root of 225 is my 15. So it doesn't matter. You can do either way. Doesn't matter. You just choose which one you want to do and simplify it. Now here it works out to, an integer, a whole number, a natural number. But they won't all necessarily work out like that. Why don't you try k on your own right now? See if you choose whichever way you want to do. Go ahead and try k on your own, okay? Give it a shot. Okay, so two ways to do it. I saw some people do it like this. They got square root of 144, which is 12. Or they divide it up, square root of 3, square root of 16, square root of 3. However you want to do it is fine. Square root of 3 times square root of 3 is 3. And square root of 16 is 4. Either way, you get 12. Okay? So you have some options when you choose to break up radicals. Okay? All right, L, what are you going to do first? Flip them. Good. 4 squared over 2 to the third. Now just evaluate. What's 4 squared? 2 to the third. Dos. That's Spanish for 2. Let's keep going. All right, let's try some harder problems. That was easy. That was kindergarten. Let's get to high school. Let's stretch our brains. Don't you love that when people say stretch your brains? Because that is really tough when you actually try to do it, when you actually try to think outside the box and try it. But that's how we learn. So it's not always, sometimes painful, and that's okay. Square root of 18 minus square root of 200. Can I just subtract 18 and 200? No, what must I do first? Must break them down, because in order to subtract square roots or add them, I must have the same radicands. Radicands are the numbers underneath the square root. In this case, we don't have that. So I can take the square root of 18, reduce that to the square root of 9 and 2. How about 200? 102. So this becomes 3 roots of 2 minus 10 roots of 2. Well, that's just like 3x minus 10x, right? So I just subtract them now. Negative 7 roots of 2. We don't actually do anything with the radicand. Like I said, it's like 3x minus 10x. We just subtract them, and that's it. Okay. I've had everybody do B on their own. I'll have you guys, but I'll give you a hint here. Let's list perfect cubes real quick, because that's what everybody has wanted. What's 1 cubed? 2 cubed? 3 cubed? 4? 5? 6? 7, 8, so on and so forth. We don't need to do them all, but that should be enough. See if you can reduce this, just like we did here, except you're using cubed roots. So you're going to have to use some of these numbers now, not your square roots, but your cubes. See if you can reduce b. Give me another 30 seconds to work through that problem, and then we're going to check to see about what you got. Okay, let's pause and see what you got up here. Cubed root of 8. Did I start this again? Yep, okay. What's the cubed root of 8? 2. So you can see cubed root of 8, cubed root of 2 give me cubed root of 16. Then cubed root of 125 and the cubed root of 2 give me cubed root of 250. What is the cubed root of 125? Times 2 is 10. So 2 cubed roots of 2, 10 cubed roots of 2, 12 cubed roots of 2. Anybody get that on their own? A few? About 5, 6. Okay. So, very similar to this one, right? Almost identical. Just we're dealing with cubes. So, got to be able to move back and forth between those two. Okay. All right, let's try an easier problem. C should be nice and easy. 3y squared times 4y to the 5th. What do I do with the 3 and 4? Multiply. I multiply coefficients when I'm asked to multiply. What do I do to the exponents? Those I add. So again, the coefficients, do whatever you're asked to do. Exponents, that's where it changes. How about D? Where would you start with D? Yep, move everything where it's not if it's negative. So I'm going to leave the a to the 8th alone. But this b to the negative 7th, I'll move that to the top. I'll move the a to the negative 5th on the bottom, create a to the 5th. And then this b to the negative 3rd, I'll just write b to the 3rd. So, a to the 8th, a to the 5th. Can I subtract those exponents? Why? Bases are not the same. Somebody had a question last hour. They said, what if I have b to the 3rd over b to the 7th? And the result was b to the negative 4th. What would you do then? Good. Drop it on the bottom. 1 over b to the 4th. Yep. That's it. Good. Sure. Yes. If you ended up inputting values, like let's say you end up with the algebraic expression, and then you later on go to plug in values and you say a is equal to 7 and b also happens to be 7, then you can make them the same. But only in that situation. So, E, true or false? These parentheses around the 2, x to the 4th, y to the 3rd, those are important. Those cannot be moved. True or false? True. True or false? The parentheses around the x and the y to the 4th, those are important. They can't be moved. False. So sometimes your book will put parentheses. Like actually, if you look back to your basic algebra book, like, sometimes you see like 3, times 2. Well, does the parenthesis around that 3 matter at all? No, it doesn't. And so, you can see that this is all multiplication up here. 3 times x times y to the fourth. It's not like you're distributing through with addition or subtraction. So we could just rewrite this as 3xy to the fourth, no parentheses needed. But these parentheses are extremely important because that exponent is going to operate on the rest of it. Okay? And so I'm going to have this 2x to the fourth and y to the third to the third. Now, if I raise an exponent to a power, what do I do? If I raise an exponent to a power, I multiply. If you raise a coefficient to a power, what do? You'll take 2 and you'll raise it to the third power. Whatever you're asked to do with the coefficients, do it. It's saying take 2 to the third. Okay, I'll do it. What's 2 to the third? It's when you get to the exponents that you do something different. Always one step lower. What's one step lower than taking to a power? Multiply. X to the 12th, y to the 9th. Now what's our operation? Addition, subtraction, multiplication, division, powers. What's our operation? Multiplication. So what do we do to our coefficients? We multiply. We do exactly what we're asked to do for the coefficients. What do we do for the exponents? One step lower, addition. Good. See if you do F on your own. Okay, let's see what you got. The first step that most people take, and again, you don't have to, but most people decide to get rid of that negative in the exponent by flipping everything. Now you have some choices. I'm curious what you do because each class has been different so far. Did you square everything or did you get rid of the negative here? That's what first hour did. They got rid of the negative. Fifth hour or fourth hour decided to square things. So let's get rid of the negative since that's what you did. If this x to the negative third goes to the bottom, it becomes x to the 6th. Now you could choose to square everything or deal with your y's. What would you like to do? Okay, if we deal with the y's, y to the fourth over y to the third becomes 2y over x to the 6th. Now when you square it, 4y squared over x to the 12th. So those are the steps that you can take. Any questions on that process? Once, twice, thrice. Okay. Now let's get to the fractions. Does everybody see that problem G is nearly identical to problem C? The only thing that's different is the exponents are fractions. We apply the same exact rules. Negative 2 times 5, negative 10. What do I do to the exponents? I add them. Here I have 3/4, here I have 3/2. How do you add fractions? Common denominators, very good. And what would the common denominator be? So turn 3/2 into fourths, 6/4, add them together, 9/4. Good. I think you guys might be asking different questions. Grace, can you ask your question again? Are you sure? Okay, the second question is in regard to an exponent. You could go like this, negative 10, 4th root of a to the 9th. If you did that, and some people do that on the test, this is okay. This is simplified. If you do this, this now has to be simplified. Because can you take a fourth root out of 8 to the ninth? Yeah, you could take an 8 to the eighth out, so you would have to then simplify that, which is okay. Some people may do that. And that's what I'm going to teach you to do right here. Does that answer your question, Clarissa? I'm so good. Actually, yours is the only class here I know all the names for. So, well, and calculus, but that doesn't really count. Okay, how about H? How is H different from the previous problem? Yeah, you got to a fractional power. Well, if I raise a power to a power, what do? Multiply. What do you do with the 4? I always do what I'm asked. It says raise it to a power, so I raise it to the power. 4 to the 3 halves. And then we're going to get to Carissa's question regarding that process. Here's where you can see this tie-in. So I have 4 to the 3 halves, and then I have an x, and I have a y. So I have x to the 6th, I have y to the 8th. I need to multiply my powers. What is 6 times 3 halves? 9. 8 times 3 halves? 12. Now, this problem would be done and done, except for the fact that we need to do with this 4 to the 3 halves. 4 to the 3 halves can be rewritten in radical form so that you maybe understand it better. Yeah, you could go to your calculator and go, 4 to the parentheses 3 divided by 2. I mean, you could do that. Or you can think of it in radical form. This is 4 to the third, and I take the square root of it. You're taking the square root of that. What's 4 to the third? 64, and the square root of 64? 8. So 8, x to the ninth, y 12. That's the correct answer. And we'll skip by. Everybody knows how to do it. What up? Yep. You're allowed to do that too. That's a good point. And that's how I generally will do the problem. People seem to struggle if I teach it that way. But to bring up Scott's point, you could actually apply the square root to all of this right away if you wanted to. You could say square root of 4 is 2. Square root of x is 6 is x to the third. Square root of y to the 8th is y to the 4th. And then apply the cube. You could do that as well. So, all right, last set. And then you guys, we're done. That's a long lesson. Good. Simplify the following expressions. Last thing we need to cover for review is how you simplify variables. A to the 4th, b to the 7th. True or false? You can take the square root of a to the 4th. True. True or false? You can take the square root of b to the 7th. False. So I have to divide it up into those I can take the square root of and those I can't. You told me you could take the square root of a to the 4th. Good. Can you take the square root of b to the 7th? You said no, so I reduce it. How about b to the 6th? So I put the b to the 6th there. What do I put over here? Just a b to the 1. That way I maintain equality. I still have 4 a's. I still have 7 b's that are being multiplied. Nothing will happen to the right side, but to the left side, I get a to the 2nd, b to the 3rd. Leave the square root of b alone. So the idea is if the index, in this case it's a 2, if that divides into the exponents, then you're good. If it doesn't, you're in trouble. So can you take the cubed root of x to the 4th? Cubed root of y to the 8th? So what we have to do is we have to create 2 separate cubed roots. One that we can, one that we can't. What do you put under the first one? X to the 3rd, y to the 6th. What are the extras that go under the next piece? So I can't do anything with the piece on the right. That's going to be done. What is the cubed root of x to the 3rd, y to the 6th? xy squared. And we have one more. What do you want to do for the last problem before you start? Multiplying both together. Let's see what we get when we multiply it out. I will end up with 1 square root of a w, and I'll have a v. W to the and v to the are those expressions that you could take the square root of. I end up with w to the third, v to the sixth. Done and done. Piece of cake. Upside down. Beautiful. Good job. Attention span. Way to go. That's a lot of review. This is something probably took you, a month or so to go through back when you're in algebra. Now we do it quick one day. Here's your assignment, section 1.2, page 23. 8, 10, 13. These 4 problems, 19 through 22 all, and then 23 through 55 odd. That ends up being about 12 more problems there. So I think you got right about, 19 problems or so to do. But it's Thursday night. And there's nothing good on TV on Thursday nights. There's a volleyball game and soccer and swim meet. And so you are busy, busy people. So I'll tell you what, your assignment is not due until test day. How's that? Wait a minute. Oh, it's 104. I thought we had till 111. Oh, all right. Okay. See you later. Good luck, Kate. Hope you got it.